Hello students, so let us solve these two questions. The first question here is based on the vibration of air column and the second question is based on Doppler's effect. So let us start with the first question. The first question says the first harmonic resonant frequency of a tube with two open ends is found to be 300 Hz. If the same tube is then closed at one end, find the new first harmonic resonant frequency. So we have a tube which is opened at both the ends. So suppose we have a tube, this is the tube and this is opened at both ends, and suppose the length of the tube is small l and speed of sound at the given conditions of temperature and pressure be v. Then the formula for the fundamental frequency or first resonant frequency of a tube which is opened at both ends is f equals to v upon 2l. So this is the formula for the fundamental frequency or first resonant frequency of an air column opened at both ends. So according to the question, it says that the first harmonic resonant frequency is 300 Hz. So let's put the values. So f is 300. So we will have 300 is equal to v upon 2l, and suppose this is our first equation. Now the further question says if the same tube is then closed at one end. Now we are going to close this tube at one end. So we will close this tube at one end. So it is opened now only at one end. Then the formula for the first resonant frequency of this tube closed at one end, that will become v upon 4l. So these are the standard results or formula you should remember. So for closed tube at one end, the fundamental or first harmonic resonant frequency is v upon 4l. So we have to find this v upon 4l value because we have to find the new first harmonic resonant frequency. So how can we calculate v upon 4l? V upon 4l can be written as half of v upon 2l. And this can be written as half into v upon 2l. We already know from equation 1 that is 300. So let's put the value here. So 300 upon 2 will be 150. So new frequency, let us say it is f prime. So the first resonant frequency of the tube closed at one end is 150 Hz, and let us see which is the correct answer. So first answer here 150 Hz, that's the correct answer for the first question. Now let's move to the second question. So this was first problem. Now we move to the second problem. Second problem is based on Doppler's effect. It says a speaker moves at a speed of 50 meters per second towards a stationary observer. So suppose we have a speaker here which is emitting sound, and we have an observer here. This speaker is moving towards the observer at a speed of 50 meters per second. Okay. And the speaker emits a sound of frequency 1000 Hz. So frequency of the actual frequency of this speaker is 1000 Hz, which is heard at a different frequency f dash. So this observer will hear a frequency different than this actual frequency, and that is known as the Doppler's effect because there is a relative motion between the source and observer here. So the frequency heard by the observer will be different from the actual frequency, and the question says that this frequency heard by the observer is f prime or f dash. Then they say that consider a different scenario in which the speaker is stationary. So this was first scenario, and in the second scenario they say that this speaker is still emitting sound, but this is now stationary and the observer moves towards the speaker at a speed of 50 meters per second. So now the observer is moving towards the speaker at the same speed of 50 meters per second. So this is second scenario. The question is at what frequency should a sound be emitted from the speaker. So what frequency f double prime, let us say it should be here, so that if the observer is to hear it at the same frequency f prime as in the first scenario. So what should be this f double prime, so that the observer still hears the sound at a frequency of f prime as he was hearing in the previous situation. So I hope you understood the question. So let us start solving this question. So we take a direction here first. So a direction, positive direction is always chosen from source to observer because sound travels from source to observer, only then the observer hears the sound. So from source to observer, this is the positive direction. So whatever velocities are parallel to this direction, they will be taken with the positive sign, and the velocities which are opposite to this direction, means opposite to the direction from source to observer, those velocities which are opposite to this, they will be taken as negative. So in the first scenario, the speaker is moving, so source is moving, so we will write velocity of a speaker or velocity of source, that will be plus 50 meters per second because motion of a speaker is parallel to this positive direction. and velocity of the observer will be 0 because the observer was stationary here. In the second scenario, the source is stationary, so Vs will be 0, and the observer is moving towards the source. So observer, if you notice here, it is moving opposite to this positive direction we have taken. So now the velocity of observer will be minus 50 meter per second because observer is moving from observer to source, and the positive direction has been taken from source to observer. So these two are opposite, that's why we have taken the observer's velocity as negative 50 meters per second. Now we will use the formula for Doppler's effect. So if you remember, the apparent frequency or frequency heard by the observer in Doppler's effect is given by f prime is equal to actual frequency and then V minus Vo divided by V minus Vs. This is a standard result, you should remember. So in the first situation here, in the first situation, f prime, that is apparent frequency, this is equal to f actual frequency is given as 1000 hertz, and let's put the value for V and V naught. And also in the second question, the sound velocity we have to take as 340 meter per second. So V is 340 we will take, and minus Vo in the first situation is 0 divided by 340 minus Vs is 50 plus 50. So from here you get f prime is equal to 1000 multiplied by 340, and this whole thing divided by 340 minus 50, and that will be 290. So this is your first equation. Now let's consider the second situation. In second situation, the apparent frequency still has to be f prime as in the first situation that is said in the question, and this will be actual frequency f, and we have to find that. We have assumed that frequency is f double prime, so now actual frequency is f double prime. V is still 340 minus Vo. In the second situation, Vo is minus 50, so we will put it minus 50 here, divided by V minus Vs, and Vs in the second situation is 0 because the source or speaker is stationary. So from here you will write f prime is equal to f double prime multiplied by 340 plus 50, that will be 390 divided by 340 minus 0, that is 340. So suppose this is your equation number 2. Now what we will do, we will compare these two equations. So you will write comparing equations 1 and 2, because the two equations 1 and 2, they have the same left hand side, so their right hand side will also be equal. So comparing these two, what do we have? We have f double prime into 390 divided by 340 is equal to 1000 multiplied by 340, and this whole thing divided by 290, and solving this you can get f double prime is equal to, this 390 will go into denominator, 340 will come into numerator, so you will have 340 into 1000 into 340, and this whole thing divided by 390 into 290, and if you solve this, what you will get f double prime is equal to 1022 hertz, and that's the answer for the second problem. So the answer to second question, that will be B, that is 1022 hertz or 1022 hertz. So I hope you understood this problem and you found it interesting.